All right, so let's talk about proportional and non-proportional relationships. Now, we're going to learn later in chapter 4 and also later in math how to solve a lot of situations using proportions. However, if you're going to use a proportion to solve something in a situation, that situation has to be proportional to begin with. Usually it's you can tell it's proportional by it having a constant change, by going up at the same amount, but not always just that. Because if you look at both these examples, the number 1 and number 2, they both go up by a constant amount, but one of them will be proportional and the other one will not because of a key difference. For example, number 1 you see goes up by 15 each time, number 2 goes up by 9 each time. So it looks like they both should be proportional, but we'll check. So here's what you need to know. Two quantities will be proportional only if they have a constant ratio between them. So meaning we're going to check the ratios of some of these values, and as long as they're all the same, constant meaning it hasn't changed, that's how we know for sure that we have a proportional situation. Now again, we want to know a situation is proportional a lot of times because it tells us, can we even use a proportion to solve it to begin with? All right, so we're going to check a few of their ratios and then we'll make our decision whether they're proportional or not. So let's start with the first one. We'll start with the first blank. We see number of hours as 1, total amount earned. We make a ratio out of that. We're going to get 1 over 15. Technically, it doesn't matter if you have this upside down, you have 15 over 1, as long as you do it in the same order for all of them, because we just want to check to see if they're the same or not. The next one gives us 2 over 30. Well, that ratio simplifies just like a fraction into 1 over 15. So that one becomes the same thing. Check the next one. That's 3 over 45. This one also simplifies, and let's see, divide top and bottom by 3. The top becomes 1, and the bottom is going to become 15, because 45 divided by 3 is 15. Now the next one, 4 over 60, I think you notice a pattern at this point. Simplify, divide top and bottom by 4, we get 1 over 15. So in this situation, all 4 of our ratios were exactly the same. Technically, you only, in my opinion, usually need to check maybe about 3 of them to know for sure. Never rely on just 2 of them, because what if you had a mistake in one of them? So I would always check at least 3 and make sure that all those ratios are the same. Don't assume they are, make sure you know that they are. So in this example, all of our ratios were the same in example 1, so we're going to describe that situation as, that situation is proportional. Proportional. So that means we can solve for anything in that situation using a proportion. We can make precise predictions of what's going to happen. Let's say at 247 hours, we can use a proportion and easily solve and know exactly what happens at 247 hours. Or we could say, how many hours will it take us to earn, let's say we want to earn $579. We can predict how many hours it'll take if we were to, in order to earn $579. Those types of things can be solved using proportions. So now let's take a look at number 2. Let's see what happens in number 2. We're going to do the exact same process. Now, just for fun, I'm going to go ahead and show you that for this one, we are going to flip it because the order really doesn't matter because we're just checking to see if they're all the same. So it really doesn't matter if you have some of them upside, as long as you have all of them upside down or all of them right side up, it really doesn't matter. In this case, I'm just putting, in the first one I put the first number on top, the second number on bottom. Here I'll put the first number on bottom, second number on top. It doesn't make an issue because we're just comparing them. So 11 over 1 does not simplify, we leave it as 11 over 1. And remember, when we do ratios, we leave improper fractions as improper fractions. Now, for the second blank, we have 20 over 2. Well, 20 over 2, that simplifies to 10 over 1. Okay, so that's our ratio for that one. Now, for the third one, we have 29 over 3. 29 and 3 are both prime, so they do not simplify. And so that is our ratio for the third blank. Now, for the fourth one, we have 38 over 4. And we ask ourselves, okay, we're simplifying that fraction, what goes into both of those? 4 does not go into both of those, but they are both even, so we know 2 goes into both of them. So divide top and bottom by 2, we'll get 19 over 2. And so that's our ratio for the fourth blank. I think you already caught on with the first, second, and definitely third, those ratios. You notice that they all were different, but our fourth one definitely was as well. Because all those ratios are different, that means that this relationship is not proportional. That's what that tells us about this relationship. It is not proportional. I keep running out of room for the word proportional. Now, that is a way to check no matter what values you're given. Here they were nice and gave us 1, 2, 3, 4. Sometimes they'll give you larger numbers or numbers that are further apart. Sometimes they'll give you things like 5, 7, 12, 14. They won't give you the same numbers up here, so you can't always just guess and see, okay, I know that if this is 0 and this is 0, here it goes up by 11, then it goes up by 9, then by 9, then by 9. So it wasn't consistent. It went up by 11 first. Whereas if you check with this one, it goes up by 1, goes up by 1, up by 1. Thank you for that. So this one goes up by 15 to get from 0 to 15, goes up by 15 again, up by 15. So this one went up by the same amount even from 0, so that one was obvious. But like I said, sometimes you won't have access to the 0 value, or sometimes these numbers up here won't go up by the same amount, and they don't need to for it to be proportional. That's why you always want to take the time to actually sometimes check your ratios for some of the relationships, for some of the moments, to make sure the ratios are constant so you know it is proportional. So that's how you check if something is proportional, yes or no. So in these examples, they were nice and they gave us a table of values. Sometimes you will not have your own table of values. So let's try another example where we're given a question but we do not have a table of values given to us. Okay, so we have our example, and this one is they didn't give us a table, but we're still going to check. The question says an ostrich can run 45 miles per hour. By the way, a quick internet search told me some ostriches have been clocked at running even faster than that. Anyways, let's say the average ostrich in good health can run 45 miles per hour. The question says, is the distance that it runs, is that distance proportional to the number of hours that it runs? So we're not given a table of values to check automatically, but in situations like this, you can make your own table of values. And so that's what we're going to do. We know the two variables that we're given are, we've got its speed. Actually, we got more than a couple variables. We got its speed, which is constant, so that's not a variable, that's constant. Then we have the distance that it runs. Obviously, you know if you run for 1 minute or 2 minutes, you're going to run longer in 2 minutes. So the distance is going to change. And the amount of time, the number of hours it runs, that's going to change based on do you keep running or do you stop running. So we got a relationship. Now, as a hint, in this relationship, we're going to use that common formula. Distance equals rate times time. Rate, otherwise known as speed, times time. That's the relationship we're going to use. So that's the type of relationship we're going to use, because you've also thought of this intuitively yourself. So let's see, let's make a table. Our first row will be number of hours. Our second line will be let's see, total distance, since those are two things that can change. Total distance, and that's what the question asked about. And right below it, we'll do our ratios. We'll try to keep them all in one spot. Okay. Now, I mentioned earlier that I recommend checking at least 3. So that's how many we're going to check. We will check 3 of them. So that'll be for hour 1, hour 2, and now hour 3. Okay, so let's see. Number of hours. After 1 hour, after 2 hours, after 3 hours. So our job is to see how far has he run. Okay, so the question told us that he could run 45 miles per hour. And so that tells us per hour, every 1 hour, he has traveled 45 miles. So after the first hour, he's only traveled 45 miles. So after the first hour, he has traveled 45 miles. Now, during the second hour, he travels another 45 miles. Well, he already traveled 45 the first time, so now he's traveled another 45. So he's traveled a grand total of 90 miles at this point. So we're at 90 miles. Now, during the third hour, as he's approaching 3 hours, he travels another 45 miles. By the way, this ostrich is an endurance runner. So now 90 miles plus another 45 miles gives us 135 miles. So at 3 hours, he's traveled a grand total of 135 miles. So our job is to answer the question, is the distance that he runs proportional to the number of hours? So we're going to find that out by checking these ratios. So let's see, the first one we have 1 over 45. That one does not simplify, that stays as 1 over 45. The second one is 2 over 90. And by the way, remember, it doesn't matter if you have these upside down of what I have, because we're just comparing them. And it doesn't matter if yours are upside down. As long as they're all in the same order, that's okay. So 2 over 90, that simplifies. Divide top and bottom by 2. We get 1 over 45. Uh-oh, so far so good. Looks like that's like the first one. But let's make sure we're not crazy. Let's check. Now, the third one, the third ratio is going to be 3 over 135. We can simplify that fraction by dividing top and bottom by 3. 3 goes into 3 one time. 3 goes into 135. Actually, I'm going to kind of cheat. Look at our table. We know if we count by 45, 90, and then 135, we know it's going to be 45 times. That's how many times 3 goes into it. So we end up with 1 over 45 again. So now in this situation, we found that our ratio was constant for all 3 of those time checkpoints at 1 hour, 2 hours, and 3 hours. So because that ratio was constant the entire time, this situation is proportional, which means we can predict with accuracy anything we want, whether it be hours, distance, anything we want using a proportion. And we do have videos on how to solve proportions. But for now, we're just talking about, is it proportional to begin with? So this situation is proportional, and you can use it to help you with solving for whether you want to know how many hours it's going to take him to run, let's say 200 miles. Even if it's not exactly a multiple of 45, that's okay. We can predict, even if the answer is going to be 4.2 hours, we can work with that because 4.2 hours exists. That means it's between 4 hours and 5 hours. So quick recap of the examples we've done. We've talked about proportional and non-proportional relationships. We said they are proportional if all the quantities have a constant ratio among the relationships. So in the example 1, they were all the same. Now, in example 2, they were not all the same. They were different. That's how we knew it was not proportional. Now, example 3, even if they don't give us our own table, we can make one based on what they're asking us to take a look at. And and we made up hours 1, 2, and 3 because we said, why not just use 1 hour, 2 hours, 3 hours? So we found that it was proportional. So remember, you can always check if it's proportional by comparing the ratios. We'll do one more example that's going to be a little bit more complicated, and we'll check that one out. Okay, in this example, let's pretend that you're ordering a bunch of pizzas, whether it be for a party, a reunion, maybe you're rewarding all the 7th graders, whatever it may be. You're ordering a bunch of pizzas. Well, you call the pizza place, and they tell you that it's $5 per pizza, and that will be a $2.50 delivery charge. So no matter how many pizzas you order, they're going to add on $2.50 to cover things like gas and insurance that they have to have on their drivers. So remember, that's not the same thing as a tip. So now let's see. The question essentially is the same as others. We want to determine right now, is this a proportional relationship, yes or no? Proportional relationship, yes or no? And notice, they did not give us a pretty chart for us to use. That's okay though. We can make one of our own, a table. We can make our own table. Now, don't be afraid to organize your thoughts with the table. That's always a great idea. So we'll make the first row, let's say number of pizzas, since that's one of the things. Because we don't know how many pizzas we're going to charge. So we want to know, is the number of pizzas proportional with the total price, is what we're going to check. Is the number of pizzas proportional with the total price that we're going to be paying? So number of pizzas is our first row. And then we'll say total cost is going to be our second row. And I'll even throw in a row for ratios so we can just have it all in one organized location. And remember, I said we only really need to check 3. That's usually enough to be able to tell, is it proportional, yes or no? So that'll be for 1, that'll be for 2, and that'll be for 3. Okay, so number of pizzas. Let's say we order 1 pizza, 2 pizzas. You know, we keep doing 1, 2, and 3. Let's maybe try some larger numbers. Let's try some larger numbers. Let's try, say 2, 3, and 4. I know that's way bigger. So 2, 3, and 4. You don't always have to start at 1. You can choose any numbers you want. You can choose 5, 8, 12. Just for simplicity's sake, I like to just keep them next to each other. All right, so let's see. The cost of 1 pizza is $5. So if we were to order only 1 pizza, we would pay $5 plus a $2.50 delivery charge. So 1 pizza would have a grand total of $7.50. However, just for fun, I made it starting off with 2 pizzas, what our table starts with. So we're going to start with 2 pizzas. So that means $5 per pizza. So just for our pizza, we're paying 2 times 5. So we're paying $10 for the pizzas, and we're paying $2.50 for the delivery charge. So that's going to be a grand total of $12.50. Now for 3 pizzas, we know that we've already paid the delivery charge here, so all we've got to do is add on another $5 at this point. So for 3 pizzas, we're going to pay $17.50. Now for 4 pizzas, we've already paid the delivery charge at this point. We're just going to add on another $5. So 4 pizzas is going to cost us $22.50. Now the question we're trying to answer is the number of pizzas and the total cost paid a proportional relationship? So we're going to check. Let's check some ratios is what we're going to do. Now, to make our division simpler, because for these we have decimals, we're not going to be able to simplify them as pretty. So because we have decimals, which you normally don't always have in fractions, but it does happen in proportions and ratios, that's okay. We're going to go ahead and do the second row on top and the top row on bottom, so that we can make our life easier. It is easier to divide by 2 and divide by 3 than it is to divide by 12.5 and divide by 17.5 or 22.5. Makes our lives a lot easier. So I'm gonna do it in that order. So for two pizzas, our ratio is going to be, make sure I'm on the right color, 12.5. I'll even put a 0 on there for 1250. You don't really need the 0 over 2. Now if we do that for all of them and keep it in that order, so 17.50 over 3, and then 2250 over 4. Notice it's hard to compare those because you can't compare fractions that we're not sure if these are exactly the same because they haven't both been simplified all the way. Technically, because of those decimal business, it's not really thinking of it as simplifying. We're just going to do this. We're going to try to turn each of them and figure out, make them each maybe, let's do our unit rate skills. Let's turn them into a unit rate like we talked about in another video. So we're going to divide top by bottom, and I switched the order so because it's easier to divide by 2 than it is to divide by 1250. So remember, whether you have one on top or the other at this point, doesn't matter. We just want to see if they're all the same. So 1250 divided by 2, that's cutting it in half. So that's like saying $12.50 divided among 2 people. Well, half of $12 is $6. Half of 50 cents is 25 cents. So that one's going to simplify down to us to $6.25 for 1 pizza is what that averages out to. That is our average cost. Remember, that included the delivery fee. That's why that was more than $5. So now we're going to do it again for the second one. We're going to do $17.50 divided by 3. I don't blame you if you don't necessarily know that right off the top of your head. So that's not a problem. We can do long division. So 17.5 divided by 3. I'll make it 17.50. So now we're going to divide by 3. Remember, when you do long division, that decimal goes straight up. So that's how you keep track of it. So now be very neat with the order you write these in. 3 goes into 1, 0 times. So go ahead and move on to the next one. 3 goes into 17, 5 times. 5 times 3 is 15. Subtract that, we get 2. Bring down the 5, that's an arrow. Now I'm erasing it, so it doesn't get too cluttered. So bring down that 5, we get 25. So now 3 goes into 25 8 times. Notice that 8 goes over the last digit that we just dropped down. 8 times 3 is 24. 25 minus 24 is 1. Bring down the 0, put the 0 there. 3 goes into 10. 3 times 3 is 9. Subtract, we're going to get 1 again. We're going to bring down a 0. We're going to keep getting a remainder of 1 over and over again. So we're going to keep getting 3's over and over again, which tells us those 3's are going to repeat. So for the sake of rounding to keep it simple, we're going to try to cut that off and round to the nearest penny, since we know we're talking money. So over here, that tells us we're going to have $5.83 over 1. So for 1 pizza on average, it's about $5.83 when we get 3 pizzas. That's our average cost. So we've now already looked at 2 of them, and we can already tell that those 2 are different. But maybe we're worried we made a mistake, and we want to make sure. So we're going to be double sure, and we're going to check this last one. So we're going to divide 4 into 2250. Because we want to be extra sure that we did not make a mistake. So now remember that decimal goes straight up and put it there now. 4 goes into 2 0 times. 4 goes into 22 5 times. 5 times 4 puts us at 20. Being good at your times tables can kind of help when you're doing long division. Subtract those, we get a 2. Bring down that 5, so we have 25 now. 4 goes into 25 6 times. 6 times 4 is 24. Now we subtract again to get our remainder. We get a remainder of 1. Bring down the 0. And so we got our 0. All right, so let's see. 4 goes into 10 twice. 2 times 4 is 8. Subtract 2, bring down another imaginary 0. We're at 20. 4 goes into 20 5 times. 5 times 4 is 20. So that tells us we're not going to have a remainder. We're going to have a remainder of 0. So that tells us 4 goes into 2250 5.625 times. But we're going to round to the nearest penny. That 5 tells us to make that penny a 3. So $5.63 is what we're working with. So $5.63 for one pizza on average is what we're working with. So let's see. We chose 3 quantities of pizzas. Remember, you could choose any quantity really. I just happened to choose 2, 3, and 4. So we noticed our ratio for 2 pizzas was 6.25 over 1. For 3 pizzas was 5.83 over 1. For 4 pizzas was 5.63 over 1. I think we'll all agree that these 3 fractions are not the same thing. So because it's not a constant ratio, in this example, this is not a proportional situation. Because remember, you always want to check the ratios to know if a situation is proportional. Once you know it's proportional, which most of what we do later in 7th grade will be proportional, you can make precise predictions about what will happen at 100 pizzas or $215. How many pizzas could you get? Obviously, they're not going to sell you a decimal of a pizza, so you'll have to round down to the lowest pizza if it was one of those situations. But just know, this is how you can always tell if a situation is proportional.